The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and thank you for joining us. My name is Justin Falkenstein, Strategic Marketing Manager at ITI, and I'll be the host for today's presentation. Today, ITI and Capvidia will be talking about trusted QIF and how QIF can be used as a mechanism to take your engineering data and your MBD information downstream into the enterprise. Today's presenters are Daniel Campbell, Vice President of Model-Based Definition at Capvidia, and Tony Prevensil, Director of Technical Sales at ITI. And in today's webinar, we're going to look at examples of how customers are already using QIF today. What is QIF and how are users unlocking the value that they're capturing in their MBD designs? And how does validation fit into this process? And how does validation benefit the process as these MBD models are reused throughout the enterprise? And how this impacts in automation and how PLM is used as a center point for collecting and distributing this information. If you have any questions throughout this presentation, please feel free to enter them into the Q&A panel and we will address them following the conclusion of today's presentation. Today's presentation is also being recorded and will be made available following the presentation today. At this time, I'll turn things over to Daniel.
All right, thank you, Justin. Hello everybody. Thanks for joining today. Let me start off by just giving a little bit of background about Capvidia for those of you who don't know. So we focus on model-based definition technology, especially in support of a lot of Industry 4.0 principles. So on the left, we have this diagram that shows some of the main pillars of the Industry 4.0 initiative, things like digital twin, big data, autonomous manufacturing, additive manufacturing, systems integrations, things like that. And the key element to all of this is that you need a digital design model in order to enable all of these things. And so that's really what we focus on, is the building block for a lot of advanced digital manufacturing techniques, which is the model-based definition. Who are we working with? I mean, we're mostly working on building out this technology and kind of, pioneering a lot of the implementation of this technology with a lot of, typically larger OEMs that are in various different industries, actually, in all different verticals. And so, I look forward to getting into this topic of model-based definition, QIF, and validated QIF. From a PLM-centric perspective, and I'd like to pass it off to Tony to give an intro on ITI.
Thank you, Daniel, and welcome everyone. ITI is a product data interoperability company. So as Daniel highlighted with the initiatives around digital transformation and Industry 4.0, ITI has served clients for decades in this area in the context of both modeling level interoperability, CAD/CAM, CAE type issues, as well as system level interoperability, PLM and ERP connectivity. So that expertise in both the integration side and the PLM world, where we partner with companies like Siemens and Dassault, PTC, Autodesk, and Aris to do integration and consolidation and migration work. As well as on the modeling side, taking that rich data that is defined in the CAD and doing things such as conversion, simplification, and reuse of that data. And today we'll focus in on both the PLM aspect as well as the validation expertise from ITI. So we will start off here with a little bit of background on QIF and how companies are using QIF to enable some of their early MBD and MBD initiatives, pushing that data downstream. So Daniel, back to you.
All right, thank you. So let's just start it off kind of, just outlining a little bit of the basic principles behind, why do we care about QIF? I mean, why do we care about model-based definition, generally speaking? What are the important principles here? So really a lot of this goes back to the idea of interoperability. What is interoperability? The ability for computer systems or software to exchange and make use of information. And so, in your software stack in your environment, it's your enterprise. Obviously, you have your CAD tool, whatever your CAD tool is, but then you have many other software tools that can potentially make use of that info. Obviously, the shape information about the shape of the part, but also there is now the 3D metadata, the model-based definition, the PMI, especially for example your GD&T, but it could be other things like welds and general notes and assembly notes and things like that. And the question is how can you exchange this data with downstream tools? And that's the challenge that standards like QIF seek to solve. You'll have the native definition of your model in a proprietary CAD format, but then you need to consume that, including the PMI information, in some other downstream tool. So for instance, maybe it's a CMM programming tool. And so it is a challenge for third-party tools to be able to consume a native model directly and to reliably consume that data. That's why interoperability formats like QIF exist. So QIF is an ISO standard format for exchanging the model data, all the PMI, and then actually there's a lot of additional quality metadata that can be specified in the QIF format and contained in the QIF format as well. So that's why QIF is such an important format and really such an emerging format, because it started to be this data format or this data framework for creating that bridge between the CAD world, the CAD and the PLM world, and other domains of manufacturing. Let me give you a little bit of a kind of a real world case, a real world use case here, just so that you can kind of wrap your mind around a concrete workflow rather than speaking in just abstractions. So we'll look at a workflow here where what we'll do is we'll start off with a native model. In this particular case, this happens to be a cryoparametric model. And this model actually is one from a mutual customer of ours, of both Capvidia and ITI, and that's the U.S. Naval Air Command, NAVAIR. Their Lakehurst division does a lot of research on additive manufacturing, and so you can see this part is a part that has sort of lightning features added to the sort of the plate underneath that holds it. So this is a pretty sort of a real world use case. We have this model. This will be contained in the PLM system. I mean, that's an important thing, is that you have to think of your PLM system as kind of the hub for all of your product related workflows. What we'll see is that after publishing this QIF MBE model automatically from the PLM, now we have a QIF ready for consumption. One of the first things that we'll do here is we'll generate some quality plans and some quality reports. This is often called the process of ballooning the model, and then generating these reports might be like a first article inspection report or a PPAP report. Depending on which industry you're in, there are different terms for these different types of inspection reports. We'll show some CMM inspection taking place from that QIF model. And then we'll show how once data is collected from real measurements on real parts, we can tie that measurement data back to the original model, so that we could extend that thread from the PLM all the way down to the as-built model. So let's go ahead and take a look at this short workflow. So again, our starting point is going to be that QIF that was published and pulled down from the PLM system. So here we're looking at the QIF. This is a derivative model that reflects the original native model. And the first thing that we'll do is we'll balloon this model, like I was saying. That's where we add these IDs to each of the characteristics so that we can identify what are the characteristics on the model that need to be qualified, that need to be measured. This table is what forms the basis for forming one of these inspection reports. And so in this case, we will create what we call an initial sample inspection report, or maybe this could be an AS9102 first article inspection report or whatever format it is, but it's the same idea. We have this data now outputted to a tabular form that's visible in Excel and consumable in Excel. And then the additional thing that we can do is we can generate a 3D HTML file that could be opened in a browser. And when that's paired with an Excel file, like we're seeing here on the left, it's a nice combination because it means that anyone who has Excel and an internet browser, which is basically to say anybody, can open the file and view it in 3D and so forth. Next, let's hop over to the CMM inspection side. So we took that QIF model that was waiting for us in PLM, and we loaded this into our CMM inspection software. In this case, we're looking at the Zeiss Calypso software, and we're seeing how it was able to generate a CMM program for that. So now we've done some inspections. We have some measurement data. We've measured, in this case, it looks like 11 parts. We have 11 different serial numbers. So we could pull those results back into the QIF format. And like I said earlier, we reestablished that thread from the PLM, the as designed part, all the way down now to these 11 as built parts. So that's kind of what we're talking about when we talk about digital twin. I mean, this is really how you start to build it up, is with MBD, with standards like QIF. So again, I mean, what we were looking at, we started off with the PLM-based QIF model, generate the quality reports, generate the 3D HTML report, do the ballooning of the model, carry out some CMM inspection, and then finally gather that information back into QIF in a digital format. And I mean, there are many other workflows other than this. I mean, that was just to give one sort of example of a pretty typical workflow that we'll work through with some of our users. But everyone's manufacturing process is different. Everyone's needs are different. And the point of MBD is that it should be molded around what your business needs are. And so, a lot of other ideas for different types of workflows that could be implemented with QIF and that we are doing with a lot of real users out there and provide a lot of value. But I think the key thing here about this slide is the center. And this is what's important to remember, is that you want to keep the PLM as the center of your this product-centric workflow. And so the PLM is the center of this. You'll have this QIF model, which should be there and should be available for consumption downstream. And the way we do this is by leveraging PLM automation, also trusting in the fact that if we're making the MBD model the center of our workflow, we want to make sure that that MBD model is correct. Because if there are issues with that MBD model, then it means that all of these processes downstreams are going to have issues right off the bat. And so that's where I would like to pass it on over to Tony so that he could talk about the importance of validation to establish the fact that the MBD model really will be correct.
Thank you, Daniel. So, what do we mean by trust? So a trusted model, as companies are looking at these digital processes, Daniel did a great job of describing how that QIF data can be an entry point for multiple downstream uses. So we're no longer depending on the CAD model just driving a drawing and that drawing being shared with people who do their work by recreating and re-entering this information. But that QIF model can be used to directly ingest it. It's an ISO standard, so it's supported by lots of different applications, and this becomes a challenging process. Drawing checking has been a thing for decades, and as we transition off, there's often this question of how do we know what this process looks like as everything gets digitized, as we go to a data-driven model instead of a document and drawing-driven model. And PLM is of course the backbone. This is where we have access control, configuration control of all of this data, And this is rich data. It's the proprietary data defining the products that we make. So PLM is a natural place where, as we create copies of this data and as we package it for collaboration with suppliers and others, being able to automate this, capture things via workflows and track this, it's really important that this data stays within this environment, that we don't have all these extra steps of exporting and taking data outside this environment, not only from a control standpoint, but also from a consistency standpoint, right? To get into quality, first we have to have predictable processes in kind of designing those MBD models and publishing that data. And as those processes get deployed, validation is the piece that lays on top of that checking and that trust. So there's a lot of complexity in this data. To go in and look at these models and check the data manually would be a very tedious and time-consuming task. It's no longer a sheet to look at. It's a 3D data set that, in order to really understand if they're complete and accurate, requires you to load it and interact with it, right? There's behavior. This data is consumed, and that behavior has to be checked as well as just the content of the data. So trusted data really ensures that that has been done. There's an automated process possible behind the scenes to compare these files and confirm that that information, not only the content, but the true semantic properties of that and how it's going to behave when it's imported into another app has been checked. And in the cases where something's been found where it's not identical, it's optimizing subject matter experts. If something needs to get routed for a human to take a look at it and say, hey, we found something here, you don't have to go and do that and spot check, lots of files. There's an automatic kind of collection of files that need to be reviewed. So the subject matter experts who have deep expertise of all this digital backbone, you can optimize their time and their expertise. What is trusted content? The first step is that it operates within that PLM context, minimize the need to take that data out and use tools at the desktop level and load applications out for end users. So analyze this data in the context of PLM, analyze it natively. So don't translate the data while you're trying to check if it's identical, but natively load it, compare the geometry, and all that rich information, the saved views, GD&T that Daniel highlighted, flowing downstream into inspection, and then widely share those results. Have an environment where users can interact and see if there are things that need to be reviewed, and share that information through standard formats like XML and PDF, so that you can generate reports to capture both the validated status of most of your data, but also to communicate questions if something does need to be communicated, either internally for review or downstream. We'll take a quick look here at workflow with that data going through the validation process. So from an automated validation process, the source is still that rich MBD model here that we see cycling through, various views of the model with a lot of rich content. And as that file is used to publish data, anyone looking at your PLM system to look at the kind of project level data can see the status of things like a QIF file and whether or not it's been validated. So at a project level, the ability to automate this and see, things have been checked. And looking at kind of the attachments here, there can be many ways to model how you store the data, but we see the QIF and the step file here within PLM. And whether that's a promotion request or something upon release, which may trigger something, or whether it's back at the user's fingertips, here looking at it back in the CAD system, a little closer look, the same content is synchronized through PLM. And we see both the data sets here, as well as user triggers to go in and do these things. So quick example of a user getting feedback on their CAD model, versus a QIF file, but they're not having to take that data out. The job gets submitted. It's processing on a server. There are queues that are managing this and synchronizing this information as these jobs run. And those reports are being automatically placed back in. So what we're seeing here is a PDF output report from this Navier part where the QIF file has been compared to the CAD file, and all those views have been activated and checked. So we get this report that can travel with that data set if we need to collect and create a data package, of various content. And that content can be QIF, it can be other formats too. So QIF is a really critical standard for connecting these downstream inspection processes, and there are often other data streams here. So the standards are critical to support kind of a limited set of content in addition to the native CAD model, and to create that synchronized, validated set of data that can be trusted for people that not only need to look at something in order to do their work, but also need to, ingest or import a file directly where they can automatically generate some of their work and really see some of those time savings downstream that everyone is aiming to implement by capturing this information up front in their CAD models. So with that, I am going to hand it back to Daniel, and we're going to wrap up with a couple tips on getting started. So Daniel, what have you observed with companies in QIF, how they get started?
Yeah, no, that's I think the critical point, because it could seem, a lot of this can seem overwhelming. I mean, the fact is that starting on an MBD implementation, well, completing an MBD implementation is a giant task. And it requires a significant change to the way that product design and manufacturing is done, and so it can feel daunting, but at the same time, I think everybody recognizes that you need to get a handle on it, because other organizations are moving forward with model-based definition, and so just from a competitive point of view, it's important to sort of get this technology under control. The good news is that, yeah, it is possible, and you do it one step at a time. And the first thing that we've seen is best is to do a big, a heavy audit of your quality processes, starting with quality, because that's kind of the lowest hanging fruit in terms of MBD and QIF. So that means, understanding who are your stakeholders downstream. That's usually generally categorized into sort of internal manufacturing category and then supplier quality category. And then what are your data artifacts? Obviously, your CAD model would be one, but there are other things too. I mean, maybe there are drawings, maybe there are that are still valid, maybe there are specs, some types of specs that are tied to the CAD model. You have inspection reports, you have measurement results that might be coming off of your CMM system, et cetera, et cetera. So just getting a handle on what all the data artifacts are. The next thing I would say would be that you want to work on setting up a QIF pilot. So identify a product that you'd like to run through this pilot, identify a project team for the execution of the pilot, and then work closely with people who have been there before. I mean, this is where I think you could really leverage the expertise of Capvidia. We've gone down this road with many users already, and are still going down this road of kind of the slow launch of gradually getting into MBD in a way that minimizes the pain while at the same time maximizing the value that you derive from it right away. So I guess, yeah, the answer to the question of how you get started is just one bite at a time. But again, I think that an important part of it is making sure that validation is a big part of it. And so, Tony, what have you seen in terms of planning validation into the process?
Well, I think your point, Daniel, is a great one about the idea of completing MBD projects being daunting. A colleague made the comment to me years ago that MBD doesn't really have a finish line. MBE, it's continuous improvement, and I think that's really a good thing to keep in mind with all this. You don't get to the finish line by accomplishing a fully integrated PLM-driven automated environment on day one with all these different formats. But as you build out this process and as you look at things like QIF and focusing on inspection, the same kind of principles layer in with validation and automation through PLM. So, validation is critical to not just try to plug in at the end. You can take steps in that pilot project to build in the infrastructure to accomplish all this. And you can do it in stepwise functions. You don't have to, so to speak, eat the elephant and accomplish an entire project. And we work with clients doing various levels, everything from small targeted processes to much larger enterprise rollouts in stage one. But it's that vision for validation. How can you build that validation process in? And the spot where we see validation coming in early is, we do see lots of companies that have contractual requirements. It states right in a contract they have that they need to use, they need to have third-party validation to confirm that copies of their CAD data are consistent and accurate across their data. So when you have those kinds of requirements, that'll pull validation forward automatically. And, the PLM process is a big part of it. That's been, a huge benefit to us working on the validation side, is leveraging the expertise of our PLM team here within ITI to be able to build out these integrations that are available today, and to work with customers on how to set up the business processes. It's not just triggering an event and you're done. How do you build this in and build a process that accelerates things in PLM and doesn't serve as roadblocks? So good points. The idea of knowing where you're starting, coming up with a defined pilot that has some measurable characteristics, and looking at the big picture and how that pilot will fit in when it comes to things like validation requirements and how best to integrate and automate these are great ideas. With that, Justin, do we have any questions from the audience? We can transition over and take some questions here as we wrap up.
Yes, absolutely. First off, thank you both very much for presenting all that information. It was great. At this time, if there are any additional questions, please feel free to enter them into the Q&A panel now. We do have a couple of questions that we can start off with here. Let's see here. How do I view a QIF file? Why can't I just open it in CAD?
Yeah, so that's a good question. So that's actually something that is a pretty common question that does come up, where people, they want to test the QIF file, and so they'll open it up. They want to open it up in their native CAD. I mean, there could be a couple problems with this. One is that there are not many CAD tools that support QIF. In fact, natively, the CAD tools themselves generally don't. Sometimes they can with plugins, but I think you have to go back to think about why don't CAD tools support that, and the reason is there isn't really a use case for it. And so this kind of goes back to you're not doing, generally speaking, QIF is not intended for creating a model in a CAD system and then loading it up in the same CAD system or another CAD system. It's not the intended use case. And so when looking at your QIF files, if you want to see if the data is there that you're expecting, the best way to do it is to open it up in the system that it's intended for. There's a variety of info that could be contained in that QIF file. And so if that QIF file was published, for instance, for coordinate metrology, then open it up in your CMM tool, not in your CAD tool, and see what it looks like there. So it just goes back to the idea of thinking about doing this audit that I talked about of your quality process, and making sure you understand what are the data artifacts and what is the tool that they're intended for, and keeping those ideas clear in your mind.
Yeah, Daniel, great points. And I think, the QIF data going downstream, I just wanted to highlight one of the things you mentioned there, which is the idea that it wasn't intended to be viewed. The QIF data doesn't inherently have the graphical elements in it. It has the definitions of things because it's intended to be imported and automatically generate content in those downstream tools. So that is a big part of it. When you want to view something, you're looking to look at something that's not there. And so the importance of looking at it downstream, and also why the validation key pops up in these newer, more robust digital formats. These formats aren't intended to be human readable, so you're not going to see them serve the purpose of lightweight viewers. They live kind of in parallel to that data within PLM.
Okay. Another question. Here's one that just came in. What other use cases besides CMM inspection, PPAP, FAI reporting exist for QIF?
Yeah, so I mean, some common ones that we've seen have been, I guess, number one is just getting beyond the basic idea of sort of ballooning and then dumping to an inspection report, but getting into more like sort of advanced product quality planning ideas. That's this APQP, linking the characteristics on the model back to product requirements in your DFMEA, linking things to your PFMEA, creating control plans, things like this. So I guess you could say like a really advanced product quality planning workflow. We have visual inspection workflows that are camera-based, sort of automated camera-based inspection that could look for defects. We've done some pretty advanced work with a company called QIF that is in this field, and they're consuming QIF data. A lot of stuff related to welds, actually. So welds, obviously, is that could be a big part of your PMI. Weld automation in terms of like robotics, the robot path planning for robotic welds, weld quality, things like that. And then I think the biggest thing sort of is at the end that I did touch on briefly is just the idea of collecting as built product data, or by the way, it could be process data as well, sort of telemetry data from certain process tools, and linking that back to the model, sort of establishing that digital thread from as designed to as built. So I would say those are some of the other areas that you see with QIF, especially with MBD. But really, I mean, honestly, anything's on the table. I mean, if you just think, what do I do with my drawing? Right now, I have a drawing, and I have a model with no annotations, and I have a drawing. What do I do with that drawing? Whatever you do with that drawing, that's on the table for putting it through an MBD workflow. And so it's really up to your imagination.
Thank you. We got another question. Could you give some examples of what is being validated? Is it limited to the geometry, or does it extend to the correctness of the tolerances? For example, flagging flatness referencing a cylinder.
Yeah, absolutely. So, typically when you're validating QIF information, you're absolutely looking at more than geometry. So the geometry is checked to ensure that is accurate from the CAD system, through the QIF model. But in addition, that data is going to include things like saved views, which display the GD&T and other elements, notes, dimensions, things like that. So essentially behind the scenes, that data is all being loaded and activated in order to check the data contextually. So if you have saved views that organize things, each of those saved views is compared and all of the elements displayed are cycled through. So that's really one of the benefits of automation. All that cycling through to check things is done automatically. And those elements are checked semantically to look at not only do they exist, but also, are the properties the same? If I highlight a flatness, feature control frame, does it highlight the same faces on the QIF file as it highlights in the native definition? So, good question.
All right. And then we do have time for one more question here. What about step AP 242?
Yeah, step AP 242 is another format that can be used downstream. QIF really has a lot of elements, in addition to what we've described today, that are focused on inspection and, a lot of the downstream processes that Daniel has highlighted. But companies that are using QIF, will also use other formats like AP 242 to enable other workflows. So there's no one size fits all, but QIF is a very important piece in connecting some of the manufacturing and inspection processes.
All right, perfect. Well, thank you very much, Daniel and Tony, and thank everyone here for attending. If you did have a question that did not get answered, do not worry. We have your questions, and we will have one of our team members reach out to you to follow up with you directly. In the meantime, if there are any other questions that were not answered throughout this presentation, feel free to reach out to the Capvidia and ITI teams, and we'd be happy to help you out. Thank you, everyone, again, for joining us today. Thank you, Daniel and Tony. And I hope everyone enjoys the rest of their week.